what we want to do now is we're going to define the definite integral. So let me draw just a general picture here. And let's say you have a function f of x, and let's say it's just kind of draw kind of a general picture here, and let's pick a point A and a point B. And so we're going to define the integral from A to B of f of x dx. This is going to equal to the what's called the signed area underneath f of x. So by signed area, what we mean is that if you remember back to the Riemann sums, we said that to find the area underneath the curve, you do your rectangle thing, and you take that to infinity. And so you have, now if you have area above the curve, above the x-axis, that's going to be different from the area that's underneath the x-axis. Can you tell why? I'll let you think about it while I finish coloring in this area here. Okay, so remember that to find the area, you multiplied the width of the rectangle, which was delta x, times the height. But remember, the height was given by the value of the function at that point. So because the value of the function is positive up here, then the area is going to be positive right here and right here. But the value of the function is negative down here, so that means that this area down here is going to be counted as negative. Okay, so if we use that definition for the integral, what we're going to do is we're going to do a couple of examples of how to use this definition graphically. And then with the fundamental theorem of calculus, we're going to connect all of the dots, and that's going to be great. So let me do an example. Let's say we've got a function. Let's say we want to find the integral between negative 3 to 2 of the function negative 2x minus 1 dx. Okay, so what we do is we interpret this as the area underneath the function negative 2x minus 1 from negative 3 to positive 2, from x equals 2, negative 3 to positive 2. So let me give you a picture. Okay, so here we have our picture, and let me draw in the area. So we're going from negative 3 to positive 2, and so if I draw this area, it looks like you've got two triangles, right? So here, this one down here is going to be negative area, and this one up here is going to be positive area. Now, since we don't have any techniques of integration, all we can do is look at this as the area of two triangles, the difference being that this one's going to be positive and this one right here is going to be negative. Okay, so here we know that let's call this one area 1, and we'll call this one down here area 2. And so let's get a little bit more space here. So let's say we want to find area 1. So let's do this right here, area 1. So we need to find the height is easy to see. We have the height of this triangle is going to be 5. And now the base is a little tricky because it goes from -3 to this point right here, but we don't know what this point is. But we need to find this point. Well, this point is simply the x-intercept of our line. So what we can do is we can find when does -2x minus 1 equal to 0. So we go, okay, well that's when x is equal to -1/2, right? So this point right here is -1/2. Okay, so then that means that the base right here from this point to -3, that's going to be 1, 2, and 1/2. So the base is equal to 2 and 1/2, or maybe I should write it as 5/2. So then what that means is that area 1 is equal to the base, which is 5/2, times the height, which is 5, times another 1/2. So this is 25/4, or 6 1/4. Okay, so that's the area of the first triangle. Now, the area of the second triangle, the height of that one is going to be also 5, if you go from here to here. And the base of this triangle, if we go from this point to this point, we see that it's 1, 2, and 1/2. Whoa. That's interesting. So 5/2 again. So the area of the second triangle is going to be the base, which is 5/2, times the height, which is 5, times 1/2. So this is also 25/4, or 6 1/4. Aha, but remember, this one we said is going to be negative area. So notice what happens is when you calculate the full area, let me erase this little guy right here. Whoop. Okay, so then the total area underneath the curve is going to be, we have the positive area, which is 6 1/4 right here, and then plus, now this area right here, this bottom one, this one's going to be negative, so -6 1/4. So then that means that the area is equal to 0. So they balance each other out. Now you might have noticed it was symmetric before, but it doesn't necessarily have to be. For example, if I would have done it from -3 to 1 right here, then it wouldn't have been symmetric, but that's just an observation. Okay, let's do another one. Okay, so we have the integral from -2 to 2 of the absolute value of x minus 1 dx. Okay, so we've got our picture here, and so what we're trying to do is find the area from -2 to +2. And so notice, just like in the previous example, we have two triangles again, but this time both of them are positive area. So all I need to do is split this up into two little triangles. And this one is kind of easier to find because the base is a whole number. So the base of this big triangle is 1, 2, 3. So the area is equal to 3 times the height, which is 1, 2, 3 over 2. So this is 9/2. We'll call this one area 1. And then this one down here, the area is equal to the base, which is 1, times the height, which is also 1, and then over 2. So this is equal to 1/2, and we'll call this one area 2. And so then the full area is equal to the first area, 9/2, plus the second area, which is 1/2. So this is equal to 10/2, or 5. So that one was way too easy. Let's do another one. Okay, so this integral from -4 to 4 of the square root of 16 minus x squared, when you first look at this, you go, whoa, this is crazy. Crazy, crazy, crazy. You go, I don't know what this is. Well, but notice, let's say you might not recognize it quite yet, but let me rewrite this. See if you recognize it after a little bit. Let's say I write this function instead of in this form, I put it as y equals to the square root of 16 minus x squared. And let's say you square both sides. Square. So then you have y squared is equal to 16 minus x squared. Interesting. Let's say you bring the x squared over. Then it turns into x squared plus y squared is equal to 16. Now, what does this look like? You recognize it? This is a circle of radius 4. Right? So this one that we have up here, this is, notice since it's only the positive square root, this one is actually a half circle of radius 4. So let's draw the graph. Okay, so you've got, this is the circle, your half circle. This is this function, the square root of 16 minus x squared, half circle of radius 4. And so to find the integral from -4 to 4, this is just basically asking you find the area underneath the curve, which is going to be positive, all of this right here. But that's just half a circle, so I can do that. The area of half a circle is equal to pi times the radius, which is 4, squared. And then since it's a half circle, we just divide it by 2. So this is equal to 8 pi. And so the integral from -4 to 4 of this crazy looking thing is simply 8 pi. That's the area right there.